Digital publishers and technical SEO professionals are facing a measurable erosion in organic traffic. Google's AI overviews and Gemini are now surfacing information directly on the results page, capturing clicks that previously reached external sites. The assumption is that this is the next iteration of search, but the traditional search hierarchy, built on established ranking mechanics, is being bypassed entirely. In response, the SEO industry is pivoting toward generative engine optimization, or GEO, attempting to engineer content to appear as a cited source within these AI-generated summaries. This strategy rests on a specific premise that generative search algorithms crawl, index, and rank authoritative information using the same stable foundation as standard search. A new empirical study of over 14,000 real-world queries suggests this premise is flawed. Generative search operates as a decoupled, unstable system that does not respond to traditional optimization tactics. The baseline architecture of traditional Google search is highly structured. It maps user intent to institutional domains, relying on objective popularity metrics like Tranco rankings to establish trust. This network visualization illustrates the architectural divergence. While traditional search connects to central hubs, generative AI models scatter their retrieval across a web of peripheral, often disconnected nodes. To test this divergence, researchers issued identical benchmark queries to standard Google search, the AI overview, and Gemini simultaneously. The objective was to measure the precise source overlap, determining if the AI systems were citing the same domains that Google ranked highest on page 1. Treating AI overviews as a summarized version of standard search ignores the underlying data. They are fundamentally distinct retrieval architectures. Since AI overviews and Gemini are both Google products, their cited sources should, in theory, closely mirror traditional Google results. To quantify the actual relationship, the study used Jacquard similarity, a metric that measures the overlap between unique sources retrieved by each system. This Venn diagram maps source overlap across 14,000 queries. Data shows a Jacquard similarity under 20% between the three systems. The overlap typically hovers between 0.11 and 0.18. Remarkably, the lowest similarity pairing is between the AI overview and Gemini. Two generative models from the same company, designed for the same platform, agree with each other the least. The evidence points to parallel, isolated retrieval silos. The data indicates that there is no longer a single, unified Google index. This divergence dictates exactly which types of websites gain visibility in generative retrieval. Traditional search heavily biases toward domains in the top 1,000 Tranco rankings, utilizing institutional reputation as a trust signal. This chart tracks AI overview sources. Red bars reveal a substantial citation drop for authoritative domains like Wikipedia, the NIH, and the Mayo Clinic. Institutional websites are frequently bypassed. Meanwhile, blue bars show significant gains for Google's properties, specifically YouTube. Generative engines consistently prioritize content over established external authorities. Standard SEO practices like link building do not appear to translate to AI visibility. The generative index utilizes a different set of priority signals that deprioritize traditional domain authority. In response to these changes, many publishers are blocking the Google Extended Crawler to prevent their data from being used for LLM training. The direct consequence is clear. These domains receive 0 citations in Gemini search results. However, Google claims that AI overviews do not require Google Extended Access, as they pull from standard search indexing. The data contradicts this. When a domain initiates a Google Extended block, citation rates in both Gemini and AI overviews plummet simultaneously. Publishers like the New York Times, Yelp, and Facebook implemented blocks to protect intellectual property, but the data shows they inadvertently reduced their AI overview presence as well. Protecting data from AI training currently functions as a visibility penalty, severing these domains from the generative search index. Effective optimization requires algorithmic consistency. For a strategy to work, the retrieval system must reliably return similar sources for the same query intent. Researchers measured this stability by introducing cosmetic edits to identical queries, minor syntax changes like contracting what is to what's. This flowchart tracks the rank-biased overlap, or RBO. Traditional search maintained a score of 0.74, while the AI overview path dropped to 0.49. A simple contraction or punctuation change caused a 30% drop in source consistency within the generative model. This volatility is not limited to text. Changing the user's device from desktop to mobile significantly alters the generated source list. This high level of volatility suggests that engineering content for high rankings is currently unreliable. When a single contraction can flip the source list by 30%, standard optimization loses its predictive power. The instability of the generative index has direct implications for users seeking factual information. The architecture often fails during trending queries, where a historical consensus has not yet been established. In one case study, users asked the engine, "Who won Jake Paul or Anthony Joshua?" The AI overview confidently declared Jake Paul the winner, a factually incorrect output for a major event. Because the generative index deprioritizes institutional authority, it bypassed credible sports journalism. Instead, it cited a satirical Facebook post as its primary factual source. A structural reliance on niche, unverified domains compromises the utility of generative search in environments where factual accuracy is paramount. Generative search operates as a parallel index that often demotes established authority in favor of fragmented, niche sources. Given the internal volatility of the system, traditional optimization tactics are currently an inefficient use of engineering resources. This has created an economic standoff. Publishers are choosing to withhold their data to protect their intellectual property and subscription models. This blockade limits the reliable data available to AI models, contributing to the continued inaccuracy of generative results. The study suggests the only stable path forward is a revenue-sharing or pay-per-crawl framework that compensates publishers for their data. Until these economic incentives are fully aligned, the generative index will continue to operate on a subset of less reliable data, remaining isolated from the authoritative web.